The block initially positioned x equals 0 and in contact with the uncompressed spring, negligible mass. The block is pushed back along the frictional surface from the position x0 to x equal minus d on the left, as shown above, compressing the spring by an amount of delta x equal d. The block is then released at the time at the position x equals 0. The block enters a rough part here of the track and eventually come to rest at the position x equal d here. The coefficient of kinetic friction between the block and the rough track is mu. Enter the rough part at this position. Okay. On the axis below, sketch and label the graph of the following two quantities as a function of position of the block between minus d and 3d. You do not need to calculate values for the vertical axis, but the same vertical scale should be used for both quantities, kinetic energy and potential energy of the block spring system. Kinetic energy of the blocks from minus d to 3d eventually come to rest at x equal d, this point. The coefficient of kinetic friction. So the kinetic friction has a certain value at minus, starting when the spring start extending forward to the right. It converts the potential energy, elastic potential energy, into the kinetic energy. Okay, it decreases to 0 at 3D. Why is that? And the parabola is like this. Is the potential energy decreases with lower and lower gradient, smaller gradient. Yeah, it makes sense. Because initially the elastic force is strong, and therefore the extension occurs with a faster rate, and therefore the potential energy decreases following this parabola. And when the extension of the spring approaches the value 0, becoming smaller and smaller, the elastic force gets smaller, and therefore the rate of the change of the potential energy decreases, and therefore the graph concave up like this, blue color for potential energy here. Potential energy decreases quadratically like this, following the formula 1/2 kx squared. This is the potential energy. So the kinetic energy will increase like symmetrically with this one, like this. Like it is like you have a reflection via this axis, where the potential energy equal to kinetic energy. Okay, right at the middle, and then that kinetic energy decreases to 0. But the problem is why it decreases up to 3D, because in the statement, the problem here, it stated that the object come to rest at x equal d, not 3D. I think there's a typo here. I think this should be 3D, not 1D. This is not from past paper. It is from like a website or another book. So typo is possible. 3D there, not 1D, because it's 1D, then the graph of kinetic energy decreases to 0 right here, not up to the 3D. Okay. So up to the 3D, that kinetic energy decreases gradually until 0 there. Okay.
Wait, what's it linear instead of quadratic?
Because the decrease of the kinetic energy 1/2 mv squared here is because of the work done by friction. We will subtract the frictional force multiplied with the distance, and this friction is a constant, which is the coefficient of friction multiplied with the normal force, and therefore the distance here is vary linearly. This is the variable with a constant like mx, and therefore the graph of kinetic energy, the later kinetic energy ek final, is a function, the function of the distance d here. Okay, which is the initial kinetic energy 1/2 mv 0 squared, the maximum kinetic energy when the object at the position x equals 0 here, x equals 0. Okay, and then minus the friction multiplied with d. This is a linear function. It is similar to y equal mx plus c. Minus fr here is the gradient m. Therefore, we have a negative gradient. Kinetic energy decreases like this. Right? Okay, going down. The d here is the variable, and 1/2 mv square here is the y-intercept, which is here the y-intercept, the maximum kinetic energy when the elastic potential energy becomes 0. Okay.
Yeah. And why is the from negative d to 0? Why is it quadratic? From negative d to 0?
Because this is the potential energy. We assume that there's no energy lost to the surrounding. Therefore, the conversion from the potential energy EP
Oh, it's the
to
same.
EK to the kinetic energy. This potential energy of the spring is 1/2 kx squared, and therefore as x varies, that potential energy decreases like this.
Yeah.
Decreases like this. The sum of these two type of energy, EP and EK, is a constant, which is the total energy. The kinetic energy must increase quadratically like this, so that the sum of those two things. For example, this value of the potential is like 1.2, and the kinetic here must be something, so that the sum is the number 5 here. Meaning that the graph is not very accurate. 3.8, like 3.8 here, 3.8 here,
Yeah.
so that the sum with 1.2, not 1.2, sorry, 1.2 is the number 5. Similarly, another point here, for example, this point, the potential energy is 0.5, the kinetic energy must be 4.5, must be here. So let me redraw the kinetic, so that the sum is the constant, the total energy. Okay, 1.2, 3.8 is here. Okay, here 2.5 and 2.5, so that the sum is 5. Here 0.5 and 4.5, so that the sum is 5. Okay. Question potential. So indicate those two things. The potential can be indicated as U here, and the kinetic is K. The next question B. The spring is now compressed twice as much to 2D. A student is asked to predict whether the final position of the block will be twice as far as 6D. The student reasoned that since the spring will be compressed twice as much as before, the block will have more energy when it leaves the spring, so it will slide farther along the track before the stopping distance x equals 6D. Which aspect of the student reasoning, if any, are correct? Explain how you write at your answer. He was partially correct, not totally correct. He is correct at the point that the stopping distance will increase, but that stopping distance is not 60. It will be 4 times 3D, which is 12D. 12D, not 6D. The reason is that the potential energy is 1/2 kx squared, and therefore when we double the x here, we have 4 times greater the potential energy. Okay, the square of 2 is 4, and therefore we have 4 times greater the potential energy, and therefore 4 times greater the kinetic energy. And so the stopping distance, which is determined by this 4k divided by the work done by friction, multiplied with the new distance. This is the new distance. The new distance will be 4 times of the old distance, which is 3D, to stop the object. Okay,
Yeah.
and therefore the new distance must be 12D, not 6D. Yeah, not 6D. So the student here is partially correct by saying that the stopping distance will be higher. About the increase of the stopping distance, because it requires further distance for the friction to do a negative work to slow down the object, slow down the object, which now has higher kinetic energy due to higher potential. Initial potential energy. However, he's not correct about the value 6D, huh? Okay, what's the next question? Which aspect is not correct? Something like that. Which aspect of the student reasoning, if any, are correct? Done. What is the which isn't are correct aspects in reasoning, if any, are correct? Wait, why is the question 1, question 2 like exactly the same thing?
No, it's asking which part is correct and which part is incorrect.
Incorrect. Okay, here I missed one word, in. Okay, he was incorrect about the stopping distance, huh? Yeah, he is incorrect about the stopping distance 6D. Okay, the actual stopping distance is 12D because the elastic potential energy is 4 times, huh? 4 times greater due to its proportionality with the square of the compression there. So when the compression double, the potential energy increases by 4 times. And so does the kinetic energy. Okay, yeah. This is the answer to question 2, huh?
Yeah.
Let me open another document to check the answer on page 9. Oh, not page 9. Okay, does not scale linearly, but quadratically. Question C. Use quantitative reasoning in clear equation as needed to help develop a definition for the new final position of block. Express your answer in term D. So I already did that here, which means that in this question B2 you do not need to mention 12D, huh? You just need to say that the stopping distance is greater than 6D because the proportionality with the square of compression, not the compression itself, not the linear relationship. Okay. Develop friction for a new final position of block here. So let me do that again with clearer writing, like the actual answer, huh? The potential energy U is 1/2 K times 2x squared, which is 4 times of this is the new U. Okay, 4 times of U. The new kinetic energy K is therefore equal to the new maximum, equal to the new maximum potential energy, which is 4 U. The kinetic energy maximum new equal to the work done by friction multiplied with the new distance. Okay, so the new distance is this 4 times of U over the friction, which is 4 times of the old distance, which is 4 times of 3D, 12D. Okay, like that.
What's FR?
The friction. sliding friction between the object and the surface, huh? Explain how any correct aspect of the student reasoning identified in part B are expressed by your mathematical relationship in part C. Explain how your relationship in part C correct any incorrect aspect of the student reasoning identified in part B. Refer to the relationship you wrote in part C, not just the final answer you obtained by manipulating those relationships. The student is correct because the kinetic energy increases with the potential energy, and the stopping distance increases with that kinetic energy, huh? And the student explain how relationship is any incorrect aspect. He is not correct. He was not correct because he assumed that the stopping distance is linearly proportional to the compression of the spring, which is incorrect. Okay. According to the mathematical relationship, part C, the student was correct because the stopping distance increases as the kinetic energy increases with the greater compression, huh? Okay. However, he was not correct. He was incorrect for the assumption that the stopping distance is proportional. Were proportional. Was proportional to the compression. It is actually proportional to the sway of the compression, huh? Indicating the final energy in the spring, which become mechanical energy of the block as it reaches the rock track, is 4 times the original energy. Part D, indicating the correct reasoning that the block has more energy in the second situation, expressed by the calculation comparing the initial energy of the spring. Yeah, which means the kinetic energy increases with the greater compression that I mentioned already. Okay. Indicating the correct reasoning that the block will slide farther, express an equation that indicates the work done by friction to stop the block in the second situation is some factor greater than the work done in the first situation. We can add another, clause here, the stopping distance, which is the ratio between the kinetic energy, huh, and the friction. Okay, frictional force there.
Yeah.
To make it even clearer, how the relationship help identify the new stopping distance, which is greater than the old stopping distance. It was incorrect. Okay. The incorrect reasoning energy scales linearly with the spring compression, corrected by the initial energy of the spring. Yeah, that's it. Okay, that question 1. This is the answer, huh? So just remove this one. Wait, so there is no more question from this document, right?
There's 4 in that document.
Okay. So this is the answer, so just remove that thing.